all living things need to create energy. And whether it be humans or bacteria, the process of cellular respiration is really important in the creation of energy in the first place, whether it be with anaerobic processes or aerobic processes. Now, this overarching term of cellular respiration can be broken down into three main parts. The first one is glycolysis. The second is the Krebs cycle. And the third one is the electron transport chain. The electron transport chain. Sometimes we'll even see the circumvention of some of these, and we'll go directly into anaerobic processes. Anaerobic meaning without oxygen. Now, taking this all in mind, the first step for cellular respiration, and its overarching term, is of course glycolysis. Now, you'll see the essential process of glycolysis in this picture here, and you don't really have to worry about all of these big words, because in today's video, we're going to be looking over the overarching process of glycolysis and what exactly it's trying to do. Now, some key things about glycolysis is that first, it happens in the cytosol of a cell. So let's just get a quick drawing of a cell in here. So you have a cell, you have a nucleus. Let's even put in some organelles here and there. Glycolysis actually happens in the cytosol, which is essentially wherever organelles are not. Cytosol itself doesn't count as an organelle and is found in every single type of cell, bacteria, animal, or plant. Now, an important thing about glycolysis happening in the cytosol is that we don't need organelles to actually complete this process, which means that bacteria without any membrane-bound organelles can actually undergo glycolysis, as well as humans and plants alike, which means that every single cell, every single living cell can undergo glycolysis and get its products. Now, secondly, an important thing about glycolysis is that it's a precursor to the rest of the ATP or energy gaining processes. So it's an overall precursor to not only aerobic respiration, but also anaerobic respiration. Now, again, aerobic essentially means with oxygen, and anaerobic means without oxygen. Now, in this first couple of videos, we'll be going over the aerobic processes because they're a little bit more complicated, and then we'll be going over anaerobic ones. Now, let's take a look at glycolysis itself. Glycolysis can be broken down into two main parts. The first one is the investment phase. And the second one is the payoff phase, the energy payoff phase. Now, just like any good businessman would do, you always have to put in something to get out some more value. And the first couple of steps, that's exactly what we do. If we look here, this ATP to ADP conversion, which happens twice in this process, we can see that we're putting in ATP, or the energy currency of the cell, and getting out ADP, which is much lower in terms of energy, which means that we're putting in energy into this process. And when we convert glucose, which is the essential precursor of glycolysis in the first place, we're seeing that we're actually losing 2 ATP in the first couple of steps. Now, as we can see here, when we're going on to the latter part of glycolysis, we're actually putting in ADP, which is much lower energy, and getting out ATP in two specific areas. You might be asking yourself, how exactly are we getting a payoff if we're putting in 2 ATPs and we're only getting back 2 ATPs again? Wouldn't that be a net of 0 energy gained? Yet, one important thing about glycolysis is that when we see a conversion between fructose 1,6-biphosphate and glyceraldehyde 3-phosphate, or dihydroxyacetone phosphate, what we're seeing is that a 6-carbon molecule, or fructose 1,6-biphosphate, is actually turning into 2 3-carbon molecules, which is G3P, glyceraldehyde 3-phosphate, essentially cleaving this 6-carbon molecule into 2, which means that this process, starting from glyceraldehyde 3-phosphate, is essentially done 2 times. So that's essentially a really basic overall look at glycolysis. We're seeing that we're actually getting ATP twice in 2 separate processes, having done 2 separate times, and we get a net output of positive energy. Overall, from glycolysis, we get a net output of 2 ATP. Additionally, when we put in NADH, we also get an output of 2 NADH. And lastly, maybe one of the most important parts about glycolysis is that we get pyruvate. And we get 2 pyruvate because anything done after this line is actually done twice. We're actually getting 2 pyruvate. And pyruvate is important because essentially what it does, I'll just quickly write it here, pyruvate, is that it essentially becomes a precursor to the next steps of cellular respiration. Whether it be through the Krebs cycle or even anaerobic respiration, pyruvate serves as an end to glycolysis and the start of the next step in the cycle. So, just to recap, we saw that glucose essentially turns into not only 2 ATP, but 2 NADH and 2 pyruvate after giving an energy payoff phase, which is done after a precursor investment phase. Additionally, glycolysis happens in the cytosol of a cell, which means that every single living cell in the universe can actually undergo glycolysis, and in the end, we see a net output which is only beneficial to us, to plants, and to bacteria, a precursor to the rest of the energy-making process.